This is a quick aside for reasons completely unknown to me. Do you like that? My voice cracked. No? I'm over 60 years old. 60 years old. Like a teenager. Like a 7, 8, 9-year-old going through puberty. My voice is cracking. Lovely. One of the joys of growing older. Can't hear, can't see. And your voice cracks. It's great. I didn't have enough fun going through puberty one time. So, here's a quick aside. For some unknown reason, some people like to express omega in RPMs, rotations per minute. But that will not fly in our world of physics where we use radians per second. So what is the conversion factor? Rotations per minute. Words work just like numbers in fractions. Words work like numbers in fractions. So dimensional analysis, as you call it, is just a matter of using words and factors, exchange factors, to get into the units you want. Minutes on the bottom, minutes on top, so they'll cancel. 1 minute in 60 seconds. 2 pi radians in one rotation. Rotations cancel, minutes canceled. We're in radians per second if we multiply by 2 pi over 60, which is pi over 30. So if you multiply omega in RPMs, rotations per minute, by pi over 30, you'll get it to radians per second. They may do this to you just to throw you off. They'll have your answer waiting for you there. You'll do it without converting it. You'll have known all of physics, but you won't have thought about the units, and you won't get your point. And I want you to get your 800. That's right. What's next up? Angular momentum. What do you suppose angular momentum does? It's always conserved. And if you have a problem, right, mv is linear momentum, so m becomes I, v becomes omega, I omega. If you have a problem that has translation and rotation in it, it all has to be put into rotation form, and you have to conserve angular momentum. There is no way to conserve linear momentum and compare it to angular momentum. Why not? Because the units are different. This is in kilogram meters per second, and this is in, remember, it's beta times mr squared, and omega is in radians per second, so this doesn't have units, so it's kilograms meters squared times omega, which is going to be in radians per second over seconds. This is in kilograms meters squared per seconds, and mv is kilogram meters per second. They're off by a factor of meters. So you can't tell me that mv can ever be compared to I omega. They're different animals in physics. They're different units. So if you can't conserve them and say that the angular momentum is going to equal the linear momentum at the beginning, like I shoot a bullet at a block of wood that can spin around. It's hanging on a string, and I shoot a bullet at it and it starts to spin around. There's rotation in that problem, and there's a linear momentum of the bullet. You cannot compare mv of the bullet before to I omega squared to I omega afterwards, because the units are different. It's like comparing a force in newtons to an hour, which is measured, in 60 times 60 seconds, right? 3,600 seconds. You can't compare seconds to newtons. You can't compare things that have different units. And one of the ways to get an 800 is to be aware of and obey the units. So we're going to get into it in the next lecture, and we're going to talk about conserving. What is angular momentum? We know it's I omega. How do we deal with it? How do we conserve it? And how do we solve problems involving angular momentum? All coming up next here on the Fred Ebert YouTube channel.